Hey guys, so just going on from the last video where I discussed an SN2 reaction, today I'll be discussing the SN1 reaction. And in this reaction, there's typically two steps. The first step involving the removal of the leaving group. Now remember, the leaving group is typically a halide, so it's an atom that's comfortable with having a negative charge because it is an electronegative atom. We consider this first step the slow step, or the rate determining step. With the removal of the leaving group, we get this positive carbocation forming. Now, a carbocation is just a carbon with a positive charge. And because of that, it allows this negatively charged nucleophile to attack the central carbon there. And this step occurs very, very fast, so the rate isn't dependent on this step alone. So because of this, we consider an SN1 reaction as a first order reaction, that being the rate is determined by the concentration of the electrophile alone and not the negatively charged nucleophile. So just to refresh your memory, in the last video I discussed about SN2 reactions favoring compounds which have primary carbons, or carbons which only have one R group attached and multiple hydrogen groups. And this was primarily because the nucleophile prefers an electrophile that isn't overly cluttered. It allows it to attack that carbon without getting in the way of any side chains or branching groups. Alternatively, the SN1 reaction actually prefers compounds which have multiple R groups attached. So we see that in primary carbons, the SN1 reaction, the rate is very, very slow. And as we start increasing the number of R groups, or the carbon side chains, the rate will start to increase. So this is one way we can compare and contrast SN1 and SN2 reactions. If it's got a primary carbon, it's typically an SN2 reaction. But if it's got a tertiary carbon, it's typically an SN1 reaction. With secondary carbons though, we see that the rates between SN1 and SN2 are very, very similar because they don't favor one or the other. So one of the big reasons why SN1 reactions favor a tertiary carbon is because of this positive carbocation here. Now, carbons don't typically like having a charge associated with them. They really don't like having a positive charge. So when we add multiple R groups to this central carbon, it helps try and stabilize this positive charge. Now, it's important to note that these R groups, or these alkyl groups, are electron donating. And this is because this carbon is slightly more electronegative than the hydrogen here. And because of this electronegative carbon, it helps stabilize this positive charge on the adjacent carbon next to it. So essentially just spreading the load of this positive charge here. So with regards to SN1 and SN2 reactions and GAMSAT, typically you'll be asked to determine whether a particular compound would favor an SN1 or SN2 reaction. Now the easiest way to go about this is to determine whether they are primary, secondary, or tertiary carbons. Now for question 1, we see that this central carbon here, the one attached to the halide, it's connected to 3 R groups, 3 carbon atoms. So this would mean that it's a tertiary carbon. And because tertiary carbons help to stabilize a positively charged carbocation, we would see that this compound would likely prefer or favor an SN1 reaction. Now for question 2, we see that there are 2 hydrogens attached to the carbon, to the central carbon, and only 1 R group. This means that it's a primary carbon. And because primary carbons are less cluttered, this molecule here would likely favor the SN2 reaction. Now in this last question, we see that the carbon that's attached to the halide, it's only got 2 R groups associated with it, or attached to it, sorry. Now this means that it's a secondary carbon, and with secondary carbons, it's much harder to determine whether the compound would favor an SN1 or SN2 reaction. So with these secondary ones, you can't really determine whether it is SN1 or SN2 based on that, the data alone. So to just finish off with a quick summary, it's important to know that an SN1 reaction is a two-step reaction. The first step being the removal of the leaving group, and this is typically the slowest step, and the second step being the addition of the nucleophile. It's also important to note that the SN1 reaction is a first order reaction, and that's why it's called SN1. And with a first order reaction, the rate is only dependent on the the electrophile itself and not the nucleophile. The last thing to remember is that SN1 reactions favor tertiary carbons. And this is because the addition or the extra R groups in a tertiary carbon help to stabilize that positive carbocation that occurs with the removal of the leaving group. If you guys got any further questions about an SN1 reaction, or if you just want some clarification on some of the things I've spoken about, please feel free to drop a comment below and I'll be sure to reply.